Hello sleuths, and welcome to Sleuth's Practical Astronomy series with me, Paul Cox, where you can learn to explore space and get the most out of your Sleuth membership. Now then, before we get into our topics today, don't forget that Helen Avery will be live at 9 p.m. Eastern with the latest instalment of her constellation stories. And if you're a dog lover, Helen's going to be talking about celestial canines, as I understand it, this evening. Anyway, look, first off, let's take a look at the current conditions at the Canary Islands Observatory. And we're going to do that first, actually, and then we're going to take a look at some of the community highlights on the discussion boards, including a great time-lapse animation of the SpaceX Tesla Roadster. For a car nut like me, it's absolutely perfect. And it was captured by the Sleuth telescopes by one of our near-Earth asteroid monitoring members, Goran. So we'll take a look at that as well. But tonight was all about your questions. And I've got a bundle of them lined up to answer, but if you've got any others, then chuck them over in the discussion boards and we'll take a look at the end of this live cast. So anyway, we're going to be taking a look at a couple of the questions that you've already sent me, including the various astronomical catalogues that you can use and some of the differences between Sleuth's telescopes. Quite a few people asked me that, been emailing me, how do I know which telescope to use for what kind of objects? So we're going to be taking a look at that a bit later. And don't forget that if you do have any other questions, post some discussion boards. We'll check that when we've covered all of the other points. And actually, I know that there's one question there from, by the way, if you don't know where this is, let's take a look. Go over to community, go over to featured threads. And here you go. Oh, look, Keith's already answered one, but it's in this top post here. So take a look down here. What's Keith asking? We'll take a look at this later, Keith. It's like, oh yeah, what perfect. We are going to be dealing with catalogs tonight because that has been a question that I had in from another email, Keith. So, but anyway, there was this other question from Michael T just above, actually, and he is asking how to set up a mission to actually one of my favorite globular clusters. These are really densely packed, quite ancient star clusters, and this particular one that Michael was asking about is 47 Tucanae. And we're going to be stepping through that whole process, which is going to uncover actually some of the different ways to set up a mission and how astronomer members can actually override some of the limits that we put in place for the Sleuth 500. And we do that to ensure that the Sleuth 500, the images, resulting images, are always as good as they can be. So we have kind of different criteria on that. But anyway, let's kick off and take a quick look, because as some of you will know, we have been, we've got some pretty pesky winter conditions, haven't we, at the Canary Islands Observatory. We've been offline for a little while now. Just look at this. I think I saw somebody post in the discussion boards today. It might have been Dave, that somebody can't remember seeing the domes this buried in the snow and the ice, and you can see there. So that lump to the left of the image. Oh, you can't actually see it. Helps if I press another button, folks, doesn't it? Oh dear, can't get the staff. That's the problem. Listen, that lump on the left hand side would go quite well with gin and tonic. That is actually dome 3, encased, and I mean encased, with ice. And it's no ordinary ice either. This is actually rime ice, and it's incredibly dense. It has virtually no air in it. When you see it, it's crystal clear. And then the dome in the middle, you can see that's dome 1, and you can see there's this kind of slightly turquoise pile of what looks like snow at the bottom of it, but that actually is ice. So that's all of the ice which has been forming on top of the dome, just like Dome 3 there, the one to the left. And because the domes are so smooth and we've got the heaters on full blast inside, the ice keeps shedding. It's like a snake sloughing its skin. What's happened, this whole snow and ice storm has been going on now for nearly a couple of weeks. So the ice accumulation has really got quite high. And what you can see actually in this image is the two shutters that you can see on Dome 1. They would normally slide down, but if they opened at the moment, they'd actually come crunching in to that pile of rock solid ice. And basically it would muck the belts up, the shutters would override each other because they'd carry on running, because the sensors wouldn't spot that they're fully open, so the motors are just still running. But look at this, the dome on the right, which is Dome 2. That is, I would estimate, full up with ice there on the north side, which is the right hand side, a good 2 or 3 feet. That's actually covering the emergency access door to that. So something I've posted in the announcements, which you may have seen, we've actually got to get the EAC guys, the Institute of Astrophysics of the Canary Islands, who manage this entire site. We're going to have to get them to actually dig out the domes, just like I did in, when was it, 2006 or something like that. But this job with this rime ice is actually going to be a pickaxe. I mean, this really is going to be one hell of a job to get that cleared. So anyway, so we have got conditions. If you look at the forecast, so if we hop back over to the website, and just as a reminder, the place to find the weather forecast, go to any of the telescope pages. So let's hop down to Slough Canary Islands 1 and scroll down, and you've got the information panel here, and you hop over to the weather panel, and there you can see the forthcoming week of a forecast. And you can see here Monday, Tuesday, and in fact most of the week, certainly conditions are improving. So now that we're not going to get any further ice, we're going to be getting the EAC guys up there, and they're going to be pickaxing the domes out of all of that ice. So hopefully we can get online again. But actually, let's just hop over to Chile, because Chile is going to be starting up, I think, actually in a couple of minutes time. So where the forecast we got there tonight, clear. So you've noticed as well actually that the All Sky camera is stuck on time a couple of days ago, and this is because there was a power outage on Friday, late on Friday, and the techs there haven't managed to get up, but our equipment's fine, it's operating. So unfortunately what we've got to do tonight though is actually monitor those first few missions to actually see whether there is any cloud, because without the All Sky camera we don't know. So let's keep an eye on that. My alarm will probably go off in a short while, reminding us, because look up here, it says observatory opens in 1 minute 35. In fact, we'll kind of probably hang around on here. So listen, what else have we got? So community highlights. We will be taking a look at some of the community highlights tonight, and actually we'll pop back to Chile when it comes online. So let's just go out. In fact, I'm just going to enlarge this. I always have my browser set a little bit smaller than normal. Let's hop over to the community discussion boards. So I'm going to go over the most recent, actually, see what's being talked about at the moment. Top one, whenever you see a bunch of numbers like that, you know it's the asteroid crowd, and they're just telling each other really what they're observing tonight, so that they don't all observe the same near-Earth asteroid or stuff like that. So they're going to have a look at that. But I'm going to scroll down, because there's one thing on here I'm looking at, and here it is. 2018-017A Tesla Roadster. Now I wondered, what on earth is that about, when this post appeared a couple of days ago? And we take a look, and this is pretty awesome. This is Goran Kasparovich, one of our near-Earth asteroid monitoring members. Actually, Goran has discovered a few nice things as well. But listen, look at this post. Look, he doesn't say very much about it. Goran is a man of very few words, but he's basically telling us this is his observation. that he made, and that's the object at the top, which rings a bell unless you've been sitting under a stone all week. Then this funny little thing here, W88, that is the Minor Planet Center observatory code for the Chile Observatory. So even if he hadn't put Chile Observatory, blah, 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 we would have known that that's the instrument, that's the observatory he'd use. And then he's told us, there we go, that's the instrument, that's the telescope, that's the CCD camera. And he's also told us when the observations were made. And the distance as well, which is something like, I think I worked it out at about 500 or 600 miles for anybody out there who wants it in imperial. But what on earth is this about? Well, let's take a look at Goran's image. This is a time-lapse animation, so it's an animated GIF. And keep an eye open. You can see there's kind of two bright stars near the center of the image, and just to the right of those, coming down the image, here it comes, there it goes, you can see a little white dot traveling down the image. Now, normally, if you spot one of Goran's missions, you know that that's probably a near-Earth asteroid or something else that he's tracking. But this, amazingly, is that car-sized object over 500,000 miles away, and Goran has captured it with the Chile telescope. How cool is that? I mean, I say it's a car-sized object. It's a car. Who would have ever thought? If somebody had asked me 14 years ago when I first joined SLU, do you reckon we'll ever be able to see a car through the SLU telescopes? It's just not a question you would have thought was going to be asked, would you? But there it is. That is Elon Musk's red Tesla Roadster car with his little astronaut Starman sitting in it, and Goran has captured that. Now then, by the way, if you wanted to capture this yourself, I'll post this a little bit. I'll post this tomorrow, actually, in the discussion boards. But you can go off to the Minor Planet Center, and they have this page here, and it's so that you can get, this is what you do to get the coordinates that you need for this particular object. And as I say, it's been designated this code down here, 2018-017A, and you can muck around with all of these things, you know, and you can change the intervals that you want it. You can change the start time that you want this data. We're going to put in here W88 for the observatory code, and scroll down here, and you can just say get ephemerides. And ephemeris is literally just a list of coordinates for an object against time. So what you do is, if you're an astronomer member, you would pick your time slot for your mission down here, and then you'd use the right ascension and the declination over here and stick those in as your coordinates. And that's just what Goran did. He did set up a few missions and then animated the result. So I'll post that little page tomorrow, but do keep an eye open in fact, I've got a full screen version of that. If you couldn't see it very well, then take a look at this. This is the full screen version of Goran's animated GIF. Just how cool is that? And loads of people discussing, and quite a few people actually in the discussion boards saying that they were going to set up some missions as well. And I know that a few people took a look at it last night, but let's hop over now. Actually, we'll go check, see if Chile has come online. Yes, it has. So we're going to hop over to the Chile 1 telescope. Here it is online. Bit green tonight. That might mean we got a bit of cloud or haze or something like that. What's this one? Current live mission. Oh, this is Uranus. So Greg P has done a Uranus mission. So actually, let's zoom in on this. Let's just use the controls in here. And a little bit fuzzy, a little bit noisy. The first images often are, because we're still kind of in semi-twilight skies. But there is Uranus in the center, or there it was. In fact, there's going to be another Uranus mission now. It's really quite a popular object. So here it comes in. Oh, look, and That is a brilliant view. So this grayscale image coming in is a brilliant way to view this. So the bright object in the center, that is the planet Uranus, discovered by Sir William Herschel, of course. But those little white dots around it, the ones well outside by the outer portal, those are stars in the background. But the 1, 2, 3, 4 small dots close to Uranus are 4 of Uranus's moons. I always think that is so cool that we can see moons of Uranus live. That's exactly where they are. And in fact, if you hop over to the discussion boards, maybe Keith or somebody can repost. There's a nice little utility that you can use from Sky and Telescope to identify which of the moons they are. And we can normally see, it depends how close they are actually to the planet, but we can sometimes see, Oberon, Titania, Ariel, and Umbral. And you can identify which ones they are. And in fact, somebody else made a post the other day that showed, in fact, it was today or this morning, I think I saw it in the discussion boards, a little animation of those moons as they orbit Uranus, which is quite cool. Anyway, listen, what we were doing, we were actually looking at, so now I can relax now because I know that the Chile Observatory is online for you lot. In fact, that is such a cool image. I am going to snap my own image of that. Just press the camera button. There it is. Let's take, ooh, look at that. That's nice. Nice image. Jolly good. Actually, I know the Washington Montessori School have just started trialing some of our education quests, and I know that Uranus is one of them. So hopefully they're going to be spotting and telling us which one those moons are. Anyway, what we were really doing just now, before I got distracted with those live telescope views, which I was doing, let's just make sure that the ultra wide field is online as well. Yes, it is. That's again, that's a bit of a dirty image. Part of that is because it's a planetary mission. The processing on it is quite harsh, but also we might have a little bit of haze tonight, so we'll keep an eye on that. But we were actually looking at community highlights, so let's hop back to featured threads this time. So what have we got? We've had a look at the Tesla. Now, if you have missed this, you have to take a proper look at this on your own screens, so that you can see this image from Peter Eilis in its full glory. This is of the constellation of Triangulum, and my machine's being a little bit slow because I'm broadcasting and streaming and making it work far too hard for a living. Now let's see if we can get this image out from Peter. Now that is of the Triangulum, the constellation of Triangulum. It is made up of 132 individual images that Peter took and processed using the Canary 3 Deep Sky telescope. So this is the best telescope for big wide views and also, faint objects like the Triangulum galaxy, which is on the right of this image. There it is. You see it in context, but I cannot explain to you, this is called a mosaic. When you piece together hundreds of images like this, it's called a mosaic. And I cannot tell you enough, cannot stress enough, just how much work is involved in piecing that many images together without seeing the joins. That's what's extraordinary. But the color of the stars is perfect. The clarity that Peter's drawn out in this is, it's one of my favorite images from the Slooh telescopes of all time, and I think probably my favorite from Canary 3 at the moment. So let's just get rid of that. I'm just going to go back here. Right, let's take another look, because hopefully everything's going okay. My machine's running a little bit slow, asking far too much of it. But there was another new one today that I spotted. And hey, Keith, great Jupiter images, by the way, recently. But look, it was this one by David Malek. and he's done an object that actually I have never heard of before. It's this number at the beginning, NGC. We're going to talk about that a little bit later when we talk about astronomical catalogues. But this one he's calling the Statue of Liberty Nebulae. And what he's saying here is it's a 5-panel mosaic from Chile 1. So he's used the Chile 1 telescopes. And just like Peter had done, he's pieced together and processed 4 or 5 panels, 5 panels to create this one whopping great image. Now, it's not a very high resolution here in the discussion boards, but hopefully David might post a link to the full-size original image. But this is an object I just have never heard of before. So I think I need to do a little bit of digging later. Can you see the Statue of Liberty in there somewhere? You know, sometimes a lot of these objects were named when we couldn't see this amount of detail. You know, a lot of them were named before we had large telescopes, CCD cameras, stuff like that. So what we see now almost overwhelms sometimes what the original observers and namers first saw in those objects. So anyway, take a quick look at that as well. What else? Oh, there is one other community post that you should be looking up, and it is noise or something moving. Now this post, this thread has been running for quite a time, but if you scroll down and you go down to Babak's post, where is it? Here. Babak N spotted something interesting in a couple of the Uranus missions that he'd snapped, and it was a moving object. And one of our asteroid, let's just take a look actually at Babak's image, and here you can see he's put a little blue arrow, which is very helpful, so we can see this little moving object. So there's Uranus down there, you can see that in the center of the image. The line is what's called a column defect on the CCD, which kind of gets accentuated in some missions because of the processing we do. But there we can see a very obvious moving object in Babak's animation that he did. And further down, one of our other asteroid hunting members, Wayne Cashwell, came up with the answer of what it was. And it's the main belt asteroid 264 Libusa. And that's another one that I had never heard of. It was discovered apparently in 1886, and it was named after the legendary, and I think legendary read mythical, founder of the city of Prague in the Czech Republic. And that little object, let's hop back up actually to that animation. That object that Babak captured is an asteroid around 31 miles across. This is an enormous chunk of primordial space rock. And for anyone in Europe, if you're still staying up late over in Europe to listen to the live cast tonight, that's around 50 kilometers or so diameter. And I said the name of it was 264 Libusa, and that means, that number actually means it was the 264th asteroid to be discovered. There you go. You learn something new every day. Now then, listen, before we take a look at the various astronomical catalogues that you can use to set up your missions, I want to tackle Michael T's question in the discussion board. So let's hop over to Michael T, and it was in this show post here. Michael T down the bottom. Where are you, Michael? Come in, Michael. Your time is up. Right, here we go. Right, Michael T says, I want to have knowledge of how to use the Chile 1 telescope to take a good shot of Tuc 47. That's 47 Tucnae. He says, I almost fell off the ladder. It was a huge Newtonian and the eyepiece and an eyepiece 10 to 12 feet off the ground. This is a telescope that he's looked through, this Newtonian telescope, and he nearly fell off the ladder when he glimpsed that cluster for the first time. And, you know, it is one of my favorite globular clusters. Now, I'm just going to start a little program up on my machine, which I had forgotten to start up beforehand. So let's take a look here. Sky capture. Transition, can you do that for me? Oh, there we go. Jolly good, that's what I like to see. Right, so here you can see a piece of planetarium software. And this is set up actually for about 10 or 15 minutes ago. It's set up for the Chile Observatory. And what we're looking at here really is just a virtual sky. Just going to zoom out a bit. Oh, I just want to make sure that you are seeing this. Yes, you are. Now then, in this is the best way. I just wanted to check, first of all, to see the visibility of it. So I'm just typing in here in the search bar, 47 Tucanae, and here we go. And you can see it's highlighted here with the little red circles down in the bottom right-hand side of the sky chart. And if I go over here, we can see that its altitude is currently around 36 degrees above the horizon. So, okay, that's what I wanted to show you there, just so that we can establish, okay, how high is this thing? Because Michael wants to capture this glorious, glorious cluster. So, excuse me, just doing a couple of other things on my machine. Now, let's hop over then and see. And this, by the way, I'm tackling this first because it ties directly into the next subject that we're going to talk about, which is using astronomical catalogues. So, if you're an apprentice or astronomer member, what you're going to want to do if you wanted to see an object like this is hop over to the telescopes and scheduled telescopes navigation. We know what kind of object it is. It's a star cluster. Now, there are several different types of star cluster, two main ones. There are open star clusters and there are globular star clusters. Now, it helps to know a little bit about the object that you want to see. So what the system's telling us now is it's just working out the best time and the best telescope. So it's going over all of the star clusters that SLU's got in our database and trawling through them to work out the best time and the best telescope to use. So here we go. The open clusters here are returned. Now, anything that's in solid and bold like this, that means they're visible at some point, probably tonight or over the next 24 hours. There we can see the butterfly star cluster. That's not visible at the moment. So just wrong time of year. So we're going to scroll down until we get to the globular cluster settings down here. So here we go, globular clusters, and there it is, the very first object under globular clusters, 47 Tucanae, and in brackets it says NGC 104, and that means it's from the new general catalogue. So that we're going to talk a little bit more about that later on. But actually, it's another invention of my somebody I've already mentioned on the show, one of my astronomical heroes, Sir William Herschel. That was where the new general catalogue, or actually for him it was called the general catalogue. 2,500 objects he put in that. But anyway, look, our problem is, look, we cannot schedule 47 Tucanae. Now, we know when we looked up that right at the beginning of the night, by the way, this is a southern hemisphere object. It can only be seen from the Chile Observatory. And we know that at the beginning of missions, it's at 35 degrees above the horizon. So it's quite low. Now, the SLU 500 method of choosing objects, because this is primarily for apprentice members, we add on some criteria that the object has to be a certain height above the horizon, and it has to be a certain size for a particular telescope, so that the images that people receive back, apprentice members receive back if they schedule a SLU 500, is the best it can be for any given night. So that's why it's not visible. It might be above the horizon, but it's not high enough to warrant a SLU 500 mission. So Michael, you might be asking yourself, what have I got to do? Have I got to wait a couple of months until it gets higher up in the sky and reappears in the pre-dawn skies? In fact, we could take a look because it might actually come back anyway. It's very far south, so it might be what's called nearly circumpolar, so it never sets because it's quite close to the southern celestial pole. But how do you then get capture an image of an object like this? Well, if you are an astronomer member, you could hop over to the By telescopes. We know it's a southern hemisphere only, so we can click on Chile telescopes. And let's hop over to following light because we know that it's quite low. So we need an early mission to do this. And there we go. In fact, I've got one there already for this. But if we did the SLU 500, now this won't at the moment return that because I tried this earlier. But sometimes, oops, wrong one. Sometimes it might because different parameters are used in here. But for this, it's even below the parameters used for this, so it's not available here. But astronomer members, you will be able to do this. So Michael, I didn't actually look up whether you are an astronomer member or not, but if you do want to capture this object, bear in mind it's low. And in fact, the system's about to tell us this, and this is how you do it. So we're going to select a catalog mission. So here we are. Here's all of the catalogs in the left. By the way, we're going to change the presentation of this because what we're going to talk about a little bit later is there's an awful lot of catalogs that SLU makes available to you, but really we want to give you the most important ones at the top of this list rather than doing it alphabetically like this. But look, we saw a little bit earlier, didn't we, that 47 Tucanae, this star cluster, is also in the new general catalogue, and we even know its number. It was 104. 104. So we pop that in there. So we've selected the catalogue in the left hand side, we've put its designation in the right hand side, which is 104, and we press the check visibility button. Now this is where SLU's system is pretty darn clever. Now this is, don't forget, you can only use select catalogue mission or enter coordinate missions if you're an astronomer member. And what we're doing here is we lower the criteria. So in this case, how high the object has to be, because we're kind of assuming that an astronomer member knows where this object is and knows the downside of imaging an object when it is so low. But look, we give this warning. So down here in yellow, hopefully you can read this, but it says NGC 104 is visible. However, it's below what we call the soft horizon. Image quality may be affected. All right, so it's giving you a warning there. This thing is low. I'll explain what the soft horizon is in a sec, but we'll just finish off this particular mission. So don't forget, as an astronomer member, you also get to select what kind of processing you want applied to this particular object. And this not only changes the real-time image processing, but in some cases it changes the type of FITS data which is generated, which is, it changes the exposure durations, it changes things called the binning levels. We're going to come on to a lot of that later on this year. But for this, it's a globular cluster, and I just happen to know that this particular globular cluster images really, really well with the globular cluster processing option. And we're just going to say schedule mission. Up it pops. Regular viewers will know I always tag anything that I've done during a show, and I can search then in my my pictures for all of the images or missions I've set up during live cast. And there you go. So there it is. There is my mission. It is low, so I'm not going to expect the best possible image. Chances are it's going to be a bit noisy because it said it was below the soft horizon. So what is the soft horizon? And if there is a soft horizon, presumably there's a hard horizon as well. Well, yes, correct. Whoever said that. The soft horizon is usually a 30-degree elevation, altitude line around the entire sky. So you'll see that soft horizon warning kick in if you're trying to image an object when it's below 30 degrees elevation. And when you're looking down that low, the telescope is having to look through so much more atmosphere that it affects the quality of the image. And sometimes we get, if there's haze or there's light cloud, often that's a lot worse out on the horizon like that. So that's why we give that warning. But astronomer members, there you go, you can override that. If you're an apprentice member and you're doing SLU 500, SLU 500 says no, if the object's below 30 degrees or below the soft horizon, it is not visible for the purpose of a SLU 500 object. So that's why we do that. But what's the hard horizon? Well, the hard horizon is the physical restriction of where either the telescope can point or the local horizon. So for instance, in Chile, we're surrounded by a couple of the Andes mountain ranges. So in the east, we've got quite a high horizon. I think it's about 15 degrees altitude, the mountains. It's quite cool, actually. Don't know if you've ever seen any of the images we've captured as the moon is rising above the Andes. It's such a cool image because you kind of get the silhouette of the mountaintop and trees and stuff like that. But equally, if you go over to the Canary Islands, well, our western horizon, that's ranges, depending on which dome, from between about 12 degrees to 20 degrees elevation. So there's no point. No one can override the hard horizon because the telescope wouldn't be looking at the object. It would be looking at the bushes or something like that, or looking at the dome wall, or looking at another telescope. But our eastern horizon, and this is something that we experimented with, a member called Bernd, Bernd often likes to try and capture comets which are just reappearing in the dawn sky, and that's very low down in the east. Well, he and I tried an experiment with one of the Canary Islands telescopes, and we managed to get some really good images when the comet was only 6 degrees above the horizon. I mean, we were both astonished. We both knew that the SLU telescopes can do some cool stuff, but frankly, we were a bit surprised by that. But anyway, so there you go, Michael. That has answered your question. I'm just going to hop over and make sure things are okay with Chile. So there you go. Coordinate mission, Alexander. Right, Alexander, he is often... Oh no, he's got in brackets here, the Duck Nebula. Because Alexander is one of our members who quite often tries to image quasars. Very, very distant galaxies. This is really, yeah. Looking back in time, he does that. Anyway, listen, so telescopes are okay. Let's take a quick look at the wide field. Yeah, that's quite cool. Let's take a look here. Duck Nebula. Can't see any nebulosity coming into this at the moment. Maybe we'll see some. Keep an eye on that, because the Duck Nebula, that's one I haven't heard of before. Anyway, what is next on our list tonight? Using different astronomical catalogues. Well, that was the reason, hopefully, it's going to put into context what we've just done there with Michael T's How Do We Find This Thing? Now, as we saw in that 47 Tucanae example, it sometimes allows you to capture objects that aren't necessarily at their optimum position in the sky by using the catalog way, choose a catalog object to set up your mission. So let's hop over to the reservation system. Telescopes, live telescopes. And let's, in the first instance, see what catalogs are available. So I'm just going to hop over to buy catalogs over here. And here we go. I'm not going to go through all of these, but I'm going to pick out 3 in particular. And the first of those is one that you don't have to have been interested in amateur astronomy for very long before you come across this word, Messier. And it's the Messier catalogue of bright extended objects. Now, what is it then? Well, this guy, I've told you before, French astronomer, Charles Messier. When did he die? I think it was 1817. So most of his work was in the kind of late 18th century and early 19th century. And he was a comet hunter. And he used to get rather frustrated because he kept panning his telescope across the sky and spotting an object and thinking, oh, great, I've got a comet. Because don't forget, his telescopes, he couldn't even resolve actually a lot of star clusters. He couldn't see that some of these globular clusters were made up of individual stars. His telescope wasn't good enough, so he saw it as a faint fuzzy patch. And actually, a globular cluster through a low-power telescope can look a little bit like the coma, the head of a comet. So he got a bit frustrated with this because every time he'd do that, what he'd have to do is he'd have to go back to that same area in the sky to see if that object had moved in between his two observations. If it had moved, then it's probably a comet. If it isn't, then he knows it's a static object. So what he did, he built up this catalogue of, in the end it turned out to be 110 objects. The biggest and brightest in primarily the northern hemisphere. Some of them go down quite low to things like the Lagoon, Eagle Nebulae, things like that, M16. They're quite southerly, but because he was a northern observer, that's primarily what the objects are that he spotted. So he made a catalogue. So every time he panned his telescope to a certain area in the sky, all he had to do was check where he was pointing, check his catalogue if he had anything in it. He could see an object there recorded. He knows, yep, move on. I wonder actually if he ever missed a comet that just happened to be in the same field of view as one of his catalogued objects. I wonder. Anyway, so that's Messier, and there's only 110 objects in there, but they are what he landed up doing, not by design, but what basically happened. The only objects he could see through his telescope, his early telescope, were the very brightest ones. And that means that the Messier catalogue actually contains some of the best looking objects in the night sky. So if you're new to SLU and you're stuck, you don't know, what shall you observe tonight? What will you set your missions up for? Why not do a little bit of a collection called the Messier catalogue? And in fact, we're coming up to the time of year, late February to March, where you can actually do something called the Messier Marathon. Now, SLU members have got together before to do this. They've all come together as a group and have split up, all using their 5 missions for certain Messier objects. And at this time of year, you can see all 110 Messier objects in a single night. Now, I believe SLU members have only succeeded in doing that once. So we've got plenty of time. If anybody's interested in setting up a SLU members Messier Marathon, then we can do so. It's quite a cool thing to do. Now, that was the Messier catalogue. Now, if you want a second thing to go on to, there's one in this list called the Caldwell. And this itself actually is not that well known. But what you can see here is Caldwell catalogue of 109 deep sky objects. So is there, by the way, of the 110 Messier objects, there's some discussion, some debate over whether or not one of those objects is real or whether it's a duplication. So there's no coincidence that this Caldwell catalogue contains 109 deep sky objects. So who was Caldwell? Well, he was a guy called Patrick Caldwell, but he was better known as Sir Patrick Moore, probably the most famous amateur astronomer who has ever lived. I had the great pride in meeting Sir Patrick on a couple of occasions, and unfortunately he died in 2012. A great loss to the amateur community. But he actually did a lot of the moon mapping for the Apollo landing. So he worked with NASA he was just absolutely fabulous lunar observer. and he'd use his telescopes in the south of England and observed and drew and mapped out so many lunar features, which NASA actually used to help plan their landing locations for the Apollo missions. So what did he come up with this catalogue for, and why is it called Caldwell? Well, Caldwell actually was his family name, and he wasn't egotistical enough to call it the Moore catalogue of 109 deep sky objects. But what he did was, he knew about the Messier catalogue, obviously, but there were a lot of southern hemisphere objects that Messier didn't know about, plus a few other objects actually that Messier just missed. So what Sir Patrick Moore did was he came up with his Caldwell catalogue of 109 more objects that certainly complement that Messier catalogue. So if you wanted to move on to something else after you've collected fabulous images of all of the Messier objects, a great extension would be the Caldwell objects, and that's going to bring the Chile Observatory southern hemisphere objects into the activity as well. Now, there is one other catalogue here that I'm going to mention tonight. I'm not going to go through all of these other ones. You can kind of Google those if you want to know about the let's just take a quick look through from the bottom, the Vandenberg catalogue of reflection nebulae. So that these other catalogues, they're all really specialist. So the Uppsala General Catalogue of Galaxies, Tycho 2.5 million stars. Tycho was a space telescope which catalogued millions and millions of stars. Sharpless catalogue of H2 regions. So that's quite a good one, but some of those objects are pretty difficult to see even in the SLU telescopes. Smithsonian Astrophysical Observatory Star Catalogue. So that's just another star catalogue. It's just stars. You put some of those in there. PNG, Strasbourg, ESO Catalogue of Galactic Planetary Nebulae. Be quite nice. Principal Galaxies Catalogue, the one that we're going to talk about in a minute. Morphological Catalogue of Galaxies, Lin's Catalogue of Bright Nebulae. IC, that's the Index Catalogue, which is actually an extension of the catalogue I'm about to talk about in a minute. The Colander Catalogue of Open Star Clusters. Now, that would be a great one to use the new Canary 3 Deep Sky Telescope for, because that's a huge field of view and a lot of open star clusters. Actually, their apparent size in the sky is quite large. So if you don't know what an open star cluster is, think about Seven Sisters. That's an open star cluster. The Hyades in Taurus, that's another open star cluster. What else have we got here? No, there's a couple there actually. So from the top, Double Star Catalogue. So that's always a good way of telling how good the viewing conditions are at the observatories. Very, very close double stars. These can either be a close binary pair, or they can be an optical pair that look as if they're very close together, but actually they can be close and far away to each other in distance from Earth. The Able Catalogue of Galaxy Clusters. Now that is quite a cool one. I'm not going to go into it now, but there are some pretty cool galaxy clusters in there where you can capture this whole little cluster, little group of galaxies. Usually those galaxy clusters are actually interacting. They're gravitationally bound to each other, but sometimes, once again, they're just an optical cluster. So some are in the far distance, some are in the foreground. The ARP Catalogue of Peculiar Galaxies, there's some pretty cool objects in there. And then there's Bennett Catalogue as well. But I'm going to hop down to this one, which is the new General Catalogue of Nebulae and Clusters of Stars. Now, this was first put together by William Herschel. William Herschel, around the same time as Messier. Herschel, born in 1738, died in 1822, just a few years after Charles Messier. But William Herschel did not do this alone, did not come up with this catalogue alone. He had his constant observatory companion by his side, and it was his sister, Caroline Herschel, one of the great unsung heroes of astronomy. William often gets, a a lot of the glory, but frankly, he would not have been able to do virtually anything that he achieved throughout his career if it hadn't been for Caroline standing by him every night, taking notes, especially when it came to cataloguing the 2,500 objects that they put together. They catalogued in 1802 in the General Catalogue. It was just called the General Catalogue at that time. They then spent the next 18 years doubling the number of objects. Now, William Herschel was a formidable telescope maker, and this is why he was able to see so many more objects than somebody like Charles Messier, because the quality of Herschel's telescopes enabled him to see more faint and smaller objects. By the way, he's one of my heroes. They both are, Caroline as well, because they did all of this work, well, a lot of this work, from my home city of Bath, in the southwest of England. And it was on the 13th of March 1781 that William discovered the planet Uranus, the first planet to be discovered through a telescope. Now, his son, we're talking about catalogues, his son John Herschel added a further 1,754 objects and published this General Catalogue of Nebulae and Clusters in 1864. So that's when all of these objects that these three people had observed and catalogued was actually published. And it was later edited by John Dreyer, another very important astronomer in the history of astronomy in the UK. And he supplemented the General Catalogue with his own discoveries, and by a load of other 19th century astronomers. And in 1888, always an easy date to remember, he published it as the New General Catalogue, which is abbreviated to NGC. And that contains 7,840 deep sky objects. Deep sky objects are nebulae, galaxies, star clusters. Virtually every object that you see in the night sky, or you can see through telescopes, usually has an NGC number. It's part of that catalogue, as well as other things. All right, so a lot of objects, they might have a Messier number, but they'll also have an NGC number along with it, and they'll also be in a whole bundle of these other catalogues as well. So it's a really good way of identifying, celestial landmarks around the night sky. And hopefully, now that you at least know what NGC means, when we did that, NGC in 104 and we were looking for 47 Tucanae, it means something now, a little bit more. So just knowing the story of how those catalogues came into being, might help. Because it's a bit daunting, isn't it? It's all these numbers and other stuff that kind of crop up in amateur astronomy when you start getting, professional astronomy as well. When you first start getting into astronomy, you start seeing people, and I often think it, if you go over to the community boards and you see people here, that one that we looked at earlier, what was it? Was it Peter or David? It was David. The title of his post starts off with NGC 3576, the Statue of Liberty Nebula. And I often think, oh no, don't be put off, anybody who's new to astronomy, don't be put off by that number. Because now you can see actually it's really simple. New General Catalogue, and that's the 303,576 object in it. Now what we do know, of course, is that certainly when those people, the Herschels or John Dreyer, when they were cataloguing 3576, it wasn't called the Statue of Liberty then, was it? Because when was the Statue of Liberty erected? I don't know. Probably, was it by 1888? I don't know. Let's have a quick look. I'm in the States at the moment. I'm over at SLU HQ in Connecticut. So Let's have a look. When was it installed? 1875. So potentially it could have been given that name, depending on who. No, because that's going to be in. I think that's going to be in the John Herschel era. So it's probably one of the objects that John Herschel would have discovered, or even no, that's actually going to be part of the objects that William discovered, because that's he went up to 5,000 objects in 1820. So that name was applied to it afterwards. Anyway, listen, what else have we got? In fact, I think we are running out of time. So I'll tell you what we'll do. If you want me to cover anything in specifically next week, then make sure you post. We'll stick a new post up for the show. And we'll look next week, because I want to cover this in quite a lot of depth, but hopefully kind of consumable, so it's not too phasing. All of Slew's telescopes, and actually I've got some great videos and stuff like that to share with you. I'll just show you one right now. Let's take a look. So I'm going to take a look in the discussion boards while you look at this. This is me doing my back in. This is in the Chile Dome, and this is mounting the new telescopes, because you might know that we replaced the old Chile 1 telescope with a brand new. Oh, look at that. You know that I'm standing on a ladder. You can't quite see how high up that is, but those rings above my head, they are 8.5 feet above ground level. By ground level, I mean concrete. That was a scary moment. That was the scariest moment I've ever had working on the telescopes. I can still feel my back twinging. Anyway, while we're looking at that, I'm just taking a look down to see if there are any other questions, because oh right, oh thanks Keith. I said earlier about if you want to identify the moons of Uranus, that there's great sky and telescope tool that you can do that with, and Keith has actually put a link to that. Oh right, and Michael T, thanks Paul. I heard and understood what you said about being an apprentice member and the current constraint about TUC 47. Sorry Michael, didn't spot that you were an apprentice member when you posted, but if ever there was a reason, all right, to upgrade to astronomer member, then that would be it. Because I agree with you, Michael, that it blows your socks off when you see that globular star cluster. I think one of the best things about it is it doesn't have an incredibly dense core. I mean, it is, first of all, an enormous star cluster, but the stars in it, and they're ancient stars, some of the oldest stars, you know, in the universe are in globular clusters. And I'm just going to change over our view on the screen. Actually, this is what we'll take a look at next week. I'm going to take you for a guided tour inside Dome 3 when we look in more depth at each one of our telescopes. And when we do that, we're going to be talking about, okay, which telescope to use for the best objects and stuff like that. So give you some guidance on that. But anyway, Michael, I agree with you. You know, 47 TUC is that the stars in it are so evenly distributed. It is almost this perfect sphere, packed full of these stars, these ancient stars, and it just looks terrific in the telescopes. In fact, Michael, here you go. We saw earlier that in a couple of nights' time, I did schedule a couple of missions to it. So why not watch one of those, and you can snap your own image of one of my missions on that, which is always a cool thing to do. And that does mean that you can grab it while it's still visible. So anyway, listen, that is probably about it for me. It's one of the most informative shows that explains and discusses the website. Oh, thanks, Rodney. Oh, Rodney, thanks very much, mate. I'll tell you, whenever the team get any little bit of feedback like this, you know, I know it's the same for Paige Godfrey when she does her Intro to Astronomy courses on Wednesdays, and Helen, who's coming up in half an hour's time. I've just got to check something. Do excuse me one moment. It really does. It means a huge amount to us. It makes all the effort worthwhile, you know, when we've put one of these shows together. Sorry, I'm trying to talk. You see, this is where Helen and Paige can do two things at once, but I can't. I'm a man. Sorry. No multitasking here. Right, sorry, I've just done that. Yes, all I was going to say was thank you very much for the feedback, because it really gives us a boost. You know, it does take quite a lot of time to kind of put all this stuff together, and certainly Paige's Intro to Astronomy course and Helen's Constellation Stories. Helen puts a huge amount of work into those live casts, and it shows, doesn't it? It really shows. And I know when they get an email from a member, or after maybe one of our events, we maybe get an email from, you know, a mum who says, oh, watching this with my daughter or son, and, you know, absolutely engaged with it and want to get a telescope and join SLU and do this, that and the other. It really makes all the effort worthwhile. So thank you. So I think there's a new rule, is basically what I'm saying, that we're only accepting good feedback from now on. So sorry, folks. It's got to be done for our own welfare, for the SLU staff, health and welfare. Anyway, listen, next week, if there is anything else that you would like me to talk about other than the telescopes, then let me know. Actually, I do just need to pick up on this one last post from Keith. So I don't know if I've answered or not. And Keith says, in your last live broadcast, you recommended that members start out with imaging the Messier, then moving on to the NGC. I'd like to amend that by suggesting that after the Messier catalogue, move on to the Coldwell, then the Bennett before the NGC. Great, Keith. Now, I promise you, I did not read this before my show. So, Keith, I'm not giving you the credit, but certainly it's great minds think alike. So I was wrong to say in one of the other shows, Messier to New General Catalogue is too much of a jump. And there are too many objects in the New General Catalogue, the NGC objects. Let's just take a quick peek here. Oh, by the way, folks, I had a little message sent to me saying, what were you showing at the beginning over the titles? And it was a little time lapse of one of the domes going up, and we're going to talk about the domes next week as well when we talk about the telescopes. But anyway, great minds think alike there, Keith. And what I hadn't mentioned though is the Bennett catalogue. So Keith here is saying do the Bennett as well before NGC. Patrick Moore made the Coldwell to include the objects that Messier missed out, while Bennett highlighted the more interesting objects in the southern hemisphere that Messier couldn't see. And Keith is from down under, so that's why he's tuned into the southern hemisphere. And Keith says, granted, there are some overlaps, but I believe those three catalogues are good choices for beginners. And I'll tell you, there is no better experienced SLU member than Keith. Keith has been with us since, well, donkey's years, and is always played an active role. And of course, I didn't mention one thing, and that was the NGC catalogue. We said there's 7,840 objects in it. Maynard Pittendray, another long time member, I think Maynard joined back in, it could have been even 2004. It was 2004, 5 or 6, one of the two. And the last time I heard, Maynard had got something like 20 objects to go before he had captured every single one of those 7,840 New General Catalogue objects using the SLU telescopes. Now, what Maynard's been doing throughout that process over the years is when he finds an error, so the object might be offset in his image, he checks its coordinates and has fed that back to me, and we've actually corrected our version of the New General Catalogue. Now, some of the corrections were our catalogue being wrong, the way we'd brought it over, but others have actually been errors in the catalogue itself. So SLU now has, I believe, one of the most accurate versions of the new general catalogue of objects that exists. So there you go. Anyway, Maynard, if you are listening, please give us an update. Have you or have you not completed your collection of 7,840 objects in the new general catalogue? And thanks very much to Keith there. So Keith, as a little reminder there, he's suggesting if you're starting off, don't know what to use telescopes for, start off by collecting all of the Messier objects. And there is no better time to do that because, as I said, all of the Messier objects are visible in a single night even over the end of February and over March. But Keith is then saying go on to the Caldwell catalogue, the one that I explained tonight, but also the Bennett catalogue. And that could be really, really useful at the moment, folks. So while the Canary Islands Observatory is closed because of all that ice, Chill is open because it's still summer down there. So the Bennett catalogue covers those Southern Hemisphere objects. So maybe even start out with the Bennett catalogue. So thanks very much, Keith, for that. Now, okay, folks, just as you see, this was 12 hours of me taking down the old dome and installing a new dome, single-handed in 12 hours. And look at this, dusk is falling, and I'm just getting there. I'm just getting there. Will I manage to get Dome 1 operating? Yes! Automatically by the end of the day. Wow. That was a long day's work. Anyway, that is it for me this week. I'll see you next week. Don't forget, Helen Avery is here in 25 minutes time. Helen, to remind you, is dealing with some, in her constellation stories tonight, she's dealing with some celestial canines. So should be interesting. I'll be listening to that. And hopefully keep your eyes open for any notices and announcements on the Canary Islands Observatory. Don't forget, we've got all of this ice to clear away. And now that the EAC tech is going to be back to work tomorrow, they're going to get the pickaxes up there, hopefully in the first half of this week. But imagine they've got this level of ice all around the site to clear up. So anyway, that's it from me tonight. I'm going to hang around and listen to Helen's show. So I'll see you all over there. 20 minutes time. Bye all. Actually in a couple of minutes time. So where the forecast we got there tonight, clear. So you've noticed as well actually that the All Sky camera is stuck on a time a couple of days ago, and this is because there was a power outage on Friday, late on Friday, and the techs there haven't managed to get up, but our equipment's fine, it's operating. So unfortunately what we've got to do tonight though is actually monitor those first few missions to actually see whether there is any cloud, because without the all sky camera we don't know. So let's keep an eye on that. My alarm will probably go off in a short while, reminding us, because look up here, it says observatory opens in 1 minute 35. In fact, we'll kind of probably hang around on here. So listen, what else have we got? So community highlights. We will be taking a look at some of the community highlights tonight, and actually we'll pop back to Chile when it comes online. So let's just go out. In fact, I'm just going to enlarge this. I always have my browser set a little bit smaller than normal. Let's hop over to the community discussion boards. So I'm going to go over the most recent, actually, see what's being talked about at the moment. Top one, whenever you see a bunch of numbers like that, you know it's the asteroid crowd. And they're just telling each other really what they're observing tonight, so that they don't all observe the same near-Earth asteroid or stuff like that. So they're going to have a look at that. But I'm going to scroll down, because there's one thing on here that I'm looking at, and here it is. 2018-017A Tesla Roadster. Now I wondered, what on earth is that about, when this post appeared a couple of days ago? And we take a look, and this is pretty awesome. This is Goran Kasparovich, one of our near-Earth asteroid monitoring members. Actually, Goran has discovered a few nice things as well. But listen, look at this post. Look, he doesn't say very much about it. Goran is a man of very few words, but he's basically some of the different ways to set up a mission, and how astronomer members can actually override some of the limits that we put in place for the SLU 500. And we do that to ensure that the SLU 500, the images, resulting images, are always as good as they can be. So we have kind of different criteria on that. But anyway, let's kick off and take a quick look, because as some of you will know, we've got some pretty pesky winter conditions, haven't we, at the Canary Islands Observatory. We've been offline for a little while now. Just look at this. I think I saw somebody post in the discussion boards today. It might have been Dave, that somebody can't remember seeing the domes this buried in the snow and the ice. And you can see there, so that lump to the left of the image, oh, you can't actually see it. Helps if I press another button, folks, doesn't it? Oh dear, can't get the staff, that's the problem. Listen, that lump on the left hand side would go quite well with gin and tonic. That is actually dome 3, encased, and I mean encased, with ice. And it's no ordinary ice either. This is actually rime ice, and it's incredibly dense. It has virtually no air in it. When you see it, it's crystal clear. And then the dome in the middle, you can see that's dome 1, and you can see there's this kind of slightly turquoise pile of what looks like snow at the bottom of it, but that actually is ice. So that's all of the ice which has been forming on top of the dome, just like dome 3 there, the one to the left. And because the domes are so smooth and we've got the heaters on full blast inside, the ice keeps shedding. It's like a snake sloughing its skin. What's happened, this whole snow and ice storm has been going on now for nearly a couple of weeks. So the ice accumulation has really got quite high. And what you can see actually in this image is the 2 shutters that you can see on dome 1, they would normally slide down, but if they opened at the moment, they'd actually come crunching in to that pile of rock solid ice, and basically it would muck the belts up. The shutters would override each other because they'd carry on running, because the sensors wouldn't spot that they're fully open, so the motors are just still running. But look at this, the dome on the right, which is dome 2, that is, I would estimate, full up with ice there on the north side, which is the right hand side, a good 2 or 3 feet. That's actually covering the emergency access door to that. So something I've posted in the announcements, which you may have seen, we've actually got to get the EAC guys, the Institute of Astrophysics of the Canary Islands, who manage this entire site. We're going to have to get them to actually dig out the domes, just like I did in, when was it, 2006 or something like that. But this job with this Rhymice is actually going to be a pickaxe. I mean, this really is going to be one hell of a job to get that cleared. So anyway, so we have got conditions. If you look at the forecast, so if we hop back over to the website, and just as a reminder, the place to find the weather forecast, go to any of the telescope pages. So let's hop down to Slough Canary Islands 1 and scroll down, and you've got the information panel here, and you hop over to the weather panel, and there you can see the forthcoming week of a forecast. And you can see here Monday, Tuesday, and in fact most of the week, certainly conditions are improving. So now that we're not going to get any further ice, we're going to be getting the EAC guys up there, and they're going to be pickaxing the domes out of all of that ice. So hopefully we can get online again. But actually, let's just hop over to Chile, because Chile is going to be starting up, I think. Hello Sleuths, and welcome to Sleuth's Practical Astronomy series with me, Paul Cox, where you can learn to explore space and get the most out of your Sleuth membership. Now then, before we get into our topics today, don't forget that Helen Avery will be live at 9 p.m. Eastern with the latest instalment of her constellation stories. And if you're a dog lover, Helen's going to be talking about celestial canines, as I understand it, this evening. Anyway, look, first off, let's take a look at the current conditions at the Canary Islands Observatory. And we're going to do that first, actually, and then we're going to take a look at some of the community highlights on the discussion boards, including a great time-lapse animation of the SpaceX Tesla Roadster. For a car nut like me, it's absolutely perfect. And it was captured by the Sleuth telescopes by one of our near-Earth asteroid monitoring members, Goran. So we'll take a look at that as well. But tonight was all about your questions. And I've got a bundle of them lined up to answer. But if you've got any others, then chuck them over in the discussion boards and we'll take a look at the end of this live cast. So anyway, we're going to be taking a look at a couple of the questions that you've already sent me, including the various astronomical catalogues that you can use and some of the differences between Sleuth's telescopes. Quite a few people asked me that, been emailing me, you know, how do I know which telescope to use for what kind of objects? So we're going to be taking a look at that a bit later. And don't forget that if you do have any other questions, post them in discussion boards. We'll check that when we've covered all of the other points. And actually, I know that there's one question there from, by the way, if you don't know where this is, let's take a look. Go over to community, go over to featured threads, and here you go. Oh, look, Keith's already answered one, but it's in this top post here. So take a look down here. What's Keith asking? We'll take a look at this later, Keith. It's like, oh yeah, what perfect. We are going to be dealing with catalogs tonight because that has been a question I had in from another email, Keith. So, but anyway, there was this other question from Michael T just above actually, and he is asking how to set up a mission to actually one of my favorite globular clusters. These are really densely packed, quite ancient star clusters, and this particular one that Michael was asking about is 47 Tucanae. And we're going to be stepping through that whole process, which is going to uncover actually